Okay, so we have a steel cone here, and let's look at this. The volume of the steel cone is 528 inches cubed, and the height of the cone is 1 foot 2 inches. So that's this part right here. So it says convert the height to inches only. So you'd go 1 times 12 to convert the 1 foot to inches. So that's 12 inches plus another 2 inches. There's 14 inches. So the height's 14 inches. So 31 says to take the volume formula of a cone and rearrange it in order to find the radius. You got to get radius by itself. So go to your formula package, go to measurement, and look up volume of a cone. So cone volume pi r squared h divided by 3. So volume equals pi r squared h divided by 3. So we got to get little r by itself. So first thing, get rid of the fraction. So you're dividing by 3, so you're going to multiply by 3 to get rid of it. So multiply by 3 both sides. So you got 3v equals pi r squared h. Okay, so now you want to get rid of the pi and the h. So you can do that at the same time because both of them are multiplying. So the opposite of multiplying is dividing. So you're going to divide both sides by pi h. That way the pi's can cross off and the h's can cross off. So what are you left with? You've got 3v over pi h equals r squared. Now, you don't want r squared, you want r. So just like you did in Pythagorean theorem, your last line to get rid of the exponent of 2, you square root both sides. That's what gets rid of the exponent of 2. So r equals the square root of 3v over pi h. Now, if we want to solve for the actual radius, we could just plug in the numbers. So if we go back up top, we had, or we can go right here. So we have volume was 528. So I'm just going to plug that in. So I've got square root 3 times the 528. And then we got divided by pi, and we found the height was 14 inches. So when I do this, I would actually work out the numerator first. So I would go 3 times 528 equals, and then you could just actually go divided by pi, and I'm going to hit equals, and then I'm going to divide it by 14 equals. So I've got the square root right now of 36.01449. So I'm going to now hit the square root of that answer. So I'm going to do square root of my answer, and I get basically 6.001. So I could pretty much say 6. Um, and that's in inches. So let's look at the next question. 32. Apply the Pythagorean theorem in order to calculate the slant length. So we go back to our diagram. We just found the radius. So the radius was 6. So if I go across here, we know that this is 6. And so we're solving for the slant length, this part right here. So we can go back to our formula package, but now you got to go into trigonometry to find Pythagorean theorem. So if we go to trigonometry, you have Pythagorean theorem, and there's your slant length right here. So c squared equals b squared plus a squared, and the c is the slant length in this case. So whether I say s or c, they're the same thing. So s or c doesn't matter. Okay, so I'm just going to put it further down here. So I'll put it off to the side here. So we've got c squared, which is slant length, a squared plus b squared. And so if I just draw quick diagrams here, that's your c, that was your slant length. The height was 14 inches. That can be a or b, doesn't matter. And then the bottom was 6 inches. So let's call the bottom b, and let's call this one a. Okay, so you're just going to sub and solve. So c squared equals 14 squared plus 6 squared. So 14 squared plus 6 squared equals 232. And then I'm going to square root both sides. And c equals square root of that, which is 15.23 inches.